Okay, so now we have some logarithmic proofs here. We need to prove something there. So we have 4 parts here. No, there are 5. So let us see the first one. The first one says, if a power x equal to a over k exponential y is equal to k exponential a, and the condition here that a is not equal to 1, so we need to show that y is equal to mx over m minus x. Now, when you observe what we need to show, there is nothing like a k, but in the given identities here, we have k, meaning all our effort should be focusing on eliminating the k. So now we can do that by either forming similar expressions of k and we equate, or whatever we shall see. Let us move on. And another thing you need to observe that we don't have an exponential. And on what we need to prove, there is nothing like an exponent, but here we have exponential, so you need to get rid of the exponent. So how do we do this? We can do that by just introducing logarithm. So let us see. Let me use the first two identities here. I have a power x equal to a over k power y. So let me first let me introduce logarithm on both sides. Let me use the natural log in ax and even here in a over k power y. When you introduce this natural log, this is ln, so x will come down and you get ln x ln a equal to y ln a over k. Okay, now when you look at this, we can call it equation 1. Now let us find, now we need to compare now this with this ax and the k power m. So we shall get ln x ln a equal to m ln k. That is if I introduce natural log on the identity of a power x equal to k power m, and I introduce the natural log ln a on both sides. So the x on a will drop down, then the m on k will also drop down. So that is equation 2. So what do you observe? Equation 1 is equal to equation 2. But now what we need is to get rid of the k. We need to get rid of the k. So here we can say that ln k is equal to x ln a over m. That is equation 3. So we can also get ln k from here. Okay, so from 1 we have x ln a equal to y. Then when you see a division, we are going to subtract. So this will be ln a minus ln k. Okay, so this is going to be x ln a equal to y ln a minus y ln k. And by the way, ln k we know it, so you can get rid of that ln k. So we shall put 3 into, let me call this one 4. So we shall get x ln a equal to y ln a minus y. Now times ln k is this. I told you when you look at this, there is something which was eliminated, and that was the k. So this is going to be y times ln k, and ln k is x ln a over m. So we can see that ln a is common throughout. So if this is ln a equal to, let me factorize ln a out, I'll be having y minus xy over m. So then a cancels, so we shall be having x equal to y minus xy over m. So it's just a matter of making y the subject now, and then we rearrange and see if we get what is required. So x will be equal to y. When factorize out y, you get 1 minus x over m. So from that, let us see our y, our x will be equal to y, this will be m minus x over, if we cross multiply and transpose, so m times 1 times x, then m times 1, which is m. So take this bracket on the left hand side, or on this side of x, so y will be equal to x times, now the reciprocal, m over m minus x, and this is y equal to mx over m minus x. This is the required proof. We have showed it. So it's just a matter of playing around with the logarithm, and now we eliminate the k. That was the idea. I eliminated the k, I was able to get what is required. So that is it. Let us go to part B. Okay, now let us see. Now we have a squared plus b squared equal to 7ab. I want you to see what we have on the other side. We have a third log of a third a plus b equal to a half log a plus log b. Now you will see that now when you have this, it was a product because this is a plus. Secondly, we don't have the squares on the number which we need to prove. So how can we get rid of these squares? Now the idea is here. We know from the binomial that a plus b raised to power 2 is going to be equal to a squared plus b squared then plus 2ab. So we need to now find this a squared plus b squared. From here it will be a plus b squared minus 2ab. Hope you get that now. So if you get that, that means we can now equate, because here I have a squared plus b squared equal to 7ab, and now we also have a squared plus b squared equal to a plus b squared minus 2ab. So that helps us now to get a number which is workable with. So we need now to use this instead of this. So we are going to replace this from this given equation. So we shall now say that a plus b squared minus 2ab is equal to, now it is 7ab. Now you can see that we are moving somewhere. Now let us take this one on the other side. We shall get a plus b squared equal to, when I take this negative 2ab on the other side, I will get 9ab. Okay, that's 7ab plus 2ab. We shall have a plus b squared equal to 9ab. Okay, so now what do we have here? How do you think they got this 3? And how do you think they got this half? Okay, so now the idea is very simple here. So when we look at this, we have a plus b, but we don't have a plus b squared. So you can just find the square root. So finding the square root on both sides, this is a plus b squared, and this is root of 9ab. So this will give us a plus b, and the other one will give us 3, then a plus b, a times b. Root is the same as a half. I think you can see this half here. Alright, now you are seeing the a plus b over 3, meaning this 3 should come this side, and we write a plus b over 3 equal to ab power half. This is the root. Now we need to find the log on both sides. Hope you can see that we have arrived at the answer. So introducing log, we shall get log of a plus b over 3 equal to, now when I take log, this power will drop, so we shall write a half log of a b. And what do we know when there is a product, we shall be separating and we add. Hence, this log of a plus b over 3 is equal to a half. Then we shall be having log a plus log b. So this is what is required in the question. Now when you look at part C, it is the same approach. Again, it is the same approach. Let us see how we do it. So here we have a squared plus b squared equal to 23ab. So we have seen that a squared plus b squared is the same as a plus b squared minus 2ab. So we shall now replace it here, and we say a plus b squared minus 2ab is equal to 23ab. We take this one on the other side. This is going to be a plus b squared equal to, when we take this other side, we shall get 25ab. I think we are receiving the same thing, same steps. Now we need to find the square root on both sides. This is going to be a plus b squared equal to the square root of 25ab. And now we shall get a plus b equal to 5ab power half. Now we need to divide by 5 as you see it here. So we shall get a plus b over 5 is equal to ab power a half. Again, introduce log on both sides. We get log of a plus b over 5 equal to log of ab power half. So the log of a plus b over 5 will be equal to, now this half will drop here. Now we shall get log, this is a product, so we shall be adding this half multiply this bracket. Okay, so that is it. Very easy, there's nothing hidden here. So the same idea, the same approach we used in B is the same, which has helped us to do C, and that is the answer. The proof is shown. So now let us talk about part D. We have given that P is equal to log base A of A cubed y power negative 2, and what Q is that one. Let us first simplify A. So P can as well be written as log of A, then this is A cubed over y squared, and our P can be log base A of A cubed. Then since this is a division, we shall take the difference. So take away log base A of y squared. So that is our p. Now q is log base a of a plus, I'm going to take a plus because this is a product, plus log base a of y squared. And now we need to find the value of p plus q. It means that p plus q will be equal to, we add these two, so we shall get log base a of a cubed minus log base a of y squared, then plus log base a of a, then plus log base a of y squared. And you can see that this can cancel with this, so we remain with 3 log base a of a plus log base a of a, which is 4 log base a of a, and we know that log base a of a is equal to 1, so p plus 2 is equal to 4. So it was very easy. Now let us see the last one. So the last one here, we are going to use an idea that when the power is operated with this log, the power will drop. So we need to show that x over y plus y over x is equal to 7. So we just need to eliminate log, I think. Yes. So, and we can see that there is a product here. No, yes, because when you say log x plus log y, that means that is log xy. Okay, let me simplify this. When I have log of x plus y over 3 squared, I can bring the square down, I can bring it down. Okay, so equal to a half. Now here we have log x plus log y, and this is also squared. So in this bracket I can convert it to log xy because it is a product. When you look at a plus here, and this half can go up. All right, let us see. So let me put this down here. I get 2 log of x plus y over 3 equal to a half. Now here I'll be having log xy, log xy squared. That is log xy squared. Okay, let me see. Okay, now take note, this half cannot come up and cancel this, see? 2, so never do that mistake, because this is log xy, the whole of it is squared. This 2 is not on xy, but it is here on the log, and this will not take us anywhere, meaning we need to modify this equation. This 2 which was here is supposed to be y squared and x squared here. Okay, so now let us repeat this number after modifying it. We have modified it. It should be log of x plus y over 3 squared equal to a half, then log of x squared plus log of y squared. Here it can be worked out. So now let us see, meaning that we have log of x plus y over 3 squared equal to, now inside the bracket we shall get log x squared y squared. So now when the square is on this, we can now simply put this a half on the as the power. So this is going to be log of x plus y 3 squared equal to log, and I have xy squared, then when I take the power it will be a half. So we shall get log of x plus y over 3 squared equal to log of xy. There we can now equate. So if we equate this x plus y squared, x plus y over 3 squared will be equal to xy. So we shall get x plus y squared over 9 equal to xy. So expand this using binomial. This is x squared plus y squared, then plus 2xy equal to 9xy. So we get x squared plus y squared equal to, take 2x squared the other side, it becomes a minus. So x squared plus y squared will be equal to 7xy. Okay, now you can see what we have, meaning we divide by xy to get 7. So divide by xy throughout, we shall get x squared over xy plus y squared over xy equal to 7. And now from here, this x cancels 1x which is up, and this y cancels 1y which is up, and finally we get it as it is required. It is x over y plus y over x equal to 7. Okay, so that is how we can do this number. So thank you for watching. Please subscribe and wait for more videos. The next video is going to be about solving logarithmic equations. Then after that we shall close the chapter with solving simultaneous logarithm equation.